Hi guys, today we are talking about inverse functions. So we've skipped to 1.5, there is no 1.4, and then 1.5a, we're going to do that in the new trimester. So today we're just going to concentrate on 1.5b. We're going to talk about what an inverse function is and how to find it. So an inverse function is, I guess it could be a relation or a function, but a relation is a set of ordered pairs. Remember that a relation just means you're carrying values from two sets together. So an xy coordinate is a relation. And then we learned that a function is when all the x values are unique, or each x value goes to exactly one y value. So x values can't repeat, but y's can. The inverse of relation is all the ordered pairs in the form yx. So basically, in an inverse, the xy and the yx, they change places. So if my function is f of x equals 2, 1, 3, 2, 4, 6, 5, 8, so it's just this collection of points, then the inverse function is going to be the same points, but the x and y's will be switched or reversed. So basically, the domain and range trade places. So one thing to keep in mind here is that this little notation, this f to the minus 1, this does not mean f raised to the power of negative 1. It means this function right here is the inverse of this one. Okay? So if this function is f of x, f minus 1 of x, that means this is the inverse. So 1, 2, 2, 3, 6, 4, and 8, 5. So that's going to be the inverse of that function. So all that happens is x and y's trade places. Alright, so if we're looking at an equation then of a function and we want to find the inverse, okay, again, x and y are going to have to trade places. So remember that f of x is the same as y. They can be interchanged. F of x equals y. So I could write this as y equals 7 over x plus 2. And then if I want to find the inverse of that, I'm just going to trade the x and y in the equation. So instead of y equals 7 over x plus 2, I'll have x equals 7 over y plus 2. So that's the first step to changing our function to the inverse. But now I need to get this y all by itself on one side in order to have the inverse function. So what I need to do here, and this one is a little bit of a trickier example, and my marker keeps doing obnoxious things. But what I need to do here is I need to solve for y, and since y is on the bottom, y is down here in the denominator, I need to think about how to get y off of the bottom of the fraction. But y is grouped with 2, so y plus 2 is kind of its own little group here. So right now 7 is divided by y plus 2, and so in order to get y out of the denominator, I'm actually going to multiply both sides of the equation by y plus 2. That will cancel out on this side, so there's no y over here anymore. On this side, I'm going to have that y plus 2 times x, and that's equal to 7. Again, this is what I'm trying to get by itself, so I want to undo first anything that's outside of my group, and then I can undo things that are inside of the group. So if this is multiplied by x, I need to undo that by dividing both sides by x. So y plus 2 equals 7 over x. And now all I need to do is subtract 2 from both sides, and I have y. So y equals 7 over x minus 2. This is the inverse function. So now that I have it back in terms of y, I can replace my f of x with my f inverse of x. This is the inverse function to this one. Okay. So the steps then that we need to go through to write an inverse function is step 1. We need to write the function replacing the f of x with y. So just take the y out of the equation, take the f of x out and replace it with y. Next, switch x and y in the equation. So swap them. Wherever you see an x, put a y, and wherever you see a y, put an x. So that's our second step. Our third step is we need to solve for y. So once we've swapped x and y in the equation, we're going to get y all by itself on one side so that it's y equals whatever. And the fourth step is we can replace that y with f inverse of x as soon as they are equal. as soon as we have one side just y. Okay, so let's go ahead and try this one. So again, first step, replace f of x with y. Then switch x and y in the equation. So x equals 1/3 y minus 5/6. Now I need to get this y out by itself. The first thing I want to do is get rid of this minus 5/6. So I'm going to add 5/6 to both sides. If I add it to that side, I get x plus 5/6. If I add it to this side, it goes away, right? And then in order to get rid of this times 1/3, when you have a fraction, what's really happening is you're timesing it by 1 and you're dividing it by 3. So we need to undo both of those. We need to times by 3 and divide by 1. I would have to do this entire side by that reciprocal. So y is equal to, and if I distribute this in, that's just really just 3, right? So 3x plus 15/6. I'm just multiplying the 3 times the 5 and the 1 times the 6. So y equals 3x plus, and if I reduce 15/6, that would be 3/2. So there's our inverse. Whoops, I forgot to replace the y with f inverse of x. So really it's the same thing, but we just put our notation there to show that this is the inverse of this one. Okay. So we'll do one more example here. We're going to change to the inverse. So first, replace that with y. Replace f of x with y. Next, change x and y in the equation. So the y becomes an x and the x becomes a y. Now I need to get this y out of here. So in order to do that, I would first have to undo this square root. So I'm going to square both sides. So x squared equals 1 minus 3y. Subtract 1 from both sides. So x squared minus 1 equals negative 3y. And then just divide by negative 3. So y equals x squared minus 1 over negative 3. And that is my inverse function because now y is all by itself on one side again. So there's my inverse function. Okay, so that's the first part of your assignment, is to change, or not to change, but to find the inverse of each function. The last part of your homework says to check if these functions are inverses. In other words, we want to show if f of f inverse of x equals x, or that f inverse of f of x equals x. It says and here, but I'm going to say or. You can do one or the other. It's going to show that these are inverse functions. So remember what this means. It's basically like taking f of f inverse of x. So we've done this a little bit. We're going to take one function, let's do this one, and we're going to plug it in where the x is here. So I'm going to take f of x, this first one here, and I'm going to take the x out and put parentheses where the x is, so minus 2 over 3. So it's the same function. I just took x out and put a parentheses where the x was. In those parentheses, I'm putting that entire other function. And then I'm going to simplify it. If it simplifies to x, then it will be an inverse. If it's anything except x, or if it won't simplify to x, that means it's not an inverse. So to me, it looks like this one is, because 3x plus 2 minus 2 is just 3x. And then 3x divided by 3 equals x. So yes, these are inverses of one another. Okay. Here we have 1 minus x squared over 3, so I'm going to write that function the same. I'm just going to replace the x with parentheses. In those parentheses, I'm going to put this second function. Okay, and now I need to check if this is true. So remember, let's do this first, this 1 minus x squared. I'm going to take that over here, and I'm going to write it as 1 minus x times 1 minus x, and we're going to multiply this out. So negative x times 1, negative x times negative x is positive x squared. So this is going to be x squared minus 2x plus 1. And then I have this minus 2. So this is actually going to be 1 minus x squared minus 2x. And then if I take this minus 2 and add it to that 1, it's going to be minus 1 over 3. Okay, so all I did here is I took this x out, and in that x's place I put this whole function. Now I am multiplying out this 1 minus x squared. I'm just putting them next to each other so I can multiply it all out. And I got x squared minus 2x plus 1. So that replaces this part, but then I would still have to subtract 2 from that. This is still squared. I haven't dealt with that yet. So now I would have to square this. This is actually quite a complicated problem. So I'm going to square x squared minus 2x minus 1 times x squared minus 2x minus 1. So x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times negative 1 is minus, oops, not 2, minus 1x squared. And then I have, and of course, okay, I'm going to erase that because my marker is being so obnoxious and we can't read it anymore. Okay, there we go. So now I'm going to go ahead and move on to the second term. So if I'm multiplying a trinomial by a trinomial, I have to multiply it by x squared by each term, then negative 2x by each term, and then negative 1 by each term. So I'm going to move on to negative 2x now. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is plus 4x squared. And negative 1 times negative 1 would become a plus 1. Now I still need to multiply this negative 1 times everything. So that would be negative x squared plus 2x and plus 1. So now I just need to combine all these like terms together, and it's going to be in here. So this would be, there's only one x to the 4th. There's a negative 2x to the 3rd and a negative 2x to the 3rd. So minus 4x to the 3rd. Get rid of this one and this one. I got a negative 2x squared and a positive 2x squared, which would be 2x squared, and then minus 1 more, so just an x squared plus x squared. And then I have a positive 1. Oh, I've got a 2x and a plus 1 and a plus 1. So plus 2x and plus 1. So we've got 1 minus that, all that stuff. So this is going to end up 1 minus 1 is 0, and all these others are going to change signs. But I can definitely see that this is not going to reduce to just an x. So these are not inverses. And that was difficult to tell. So basically, plug one into the other, simplify it. If it does not simplify to just equaling x, then it is not an inverse. Okay, so these ones were not inverses. Okay, so that's pretty much all that you're doing today. Again, if you have questions, you're welcome to either hop onto Zoom to ask them, email me. But have a great day, and just make sure that you look on Canvas for your assignments for the next couple days.